Hello everyone, welcome to Super SEO again. This is now a part 2 of the continuous random variable. We started in video part 1. Now, again, as before, I need to show you this disclaimer from Cambridge. All right, so now this again here is, in terms of extension 1 textbook of the Cambridge, is chapter 16b, and in terms of 2-unit or advanced maths course, it's chapter 10b. So just bear in mind the difference of the numbering of the chapters, but the questions are the same. All right, so today we're going to focus on the questions 4, 5, and 6, and then the next video we're going to start having a look at the development questions in that section. All right, so question 4. So that's what it says. I'm going to explain why I've highlighted that and saying that that's what it looks like a typo in a minute when we get to that section. So that's what the question 4 is asking you to do. So sketching, and part B, show that it's the PDF, and then part C is the actual calculation using that given definition. All right, so let's go on. So we have the very first question. Notice I'm skipping question 3 because question 3 here is what it looks like, and this is basically a quadratic function, which is similar to that question there in question 2f, which I covered in the first video, so you can have a look at that. So that's why I'm skipping that question 3. So jumping on to question 4. All right, so question 4, so that's the little f of x that we got given with. So that's a quarter, and obviously it's a positive in that domain. And so that's the sketch. It's pretty simple straight line. Now notice it has to stop there because the domain is between 0 and 4. All right, part B. So remember, you had to show that it's actually a PDF. So the first condition is pretty much ticked off because it's positive. Quarter is obviously positive. And now the definite integral evaluation. So from 0 to 4, a quarter, and dx. Now, notice I haven't actually done the actual integration. I noticed that this is basically, to do that, performing that integration is basically finding the area under that curve. In this case, a straight line, but we can generally say it's a curve. So, I mean, if you want, you can just do the usual integration, or, you can just do, noticing that this is going to form a nice rectangular area. So just use the area formula for the rectangle, which is going to be quarter times 4, which is what expected, gives you 1. So therefore, this is a probability density function. Now, part C is all of these little probabilities that you have to calculate. First one is the probability between 0 and 1. And according to the definition, it's the integral, the definite integral from 0 to 1, and that being the h and that being the k, or which the other way around, I don't remember what that was, but okay. So that's a quarter times the width, which is 1, so that's a quarter. So the probability of whatever the continuous random variable here, x, is defined to be, found between 0 and 1 is a quarter. So about 20, that's not about exactly 25% in terms of the percentage. Probability of that variable between 1 and 3 is a quarter times the width. In this case is 3 times 3 take away 1, which is 2. So that's now half. Okay, and that's x less than or equal to 2. Even though it says less than or equal to 2, according to the definition, the integration has to go from negative infinity to 2. Because the domain is stopped at 0, that means the same as saying the probability of finding the continuous, that random variable between 0 and 2. So it's going to be then quarter times 2, because that's the width. Or integral of 0 to 2 integral of 0 to 2 and quarter dx, and that's going to give you the same result here. Okay. All right. So now this is the part. The actual question says p of x equals to 2. Now, if you read it carefully, what that means is probability of whatever that random variable is to be 2. I mean, that doesn't make any sense because you can't have a probability greater than 1 anyway. So my guess is the probability of x, the continuous random variable, is exactly the same as 2. All right, well, that's going to be 0 because in terms of the integral, what does that mean? That's the integral of 2 to 2 of a quarter dx, and those two are the same, so that has to be 0. We know that from integration knowledge, so that's why it's 0. Okay, so it's pretty interesting because what that means is whatever the continuous random variable defined to be, exactly the same as 2 is going to be 0. So there's no way for you to find that sitting exactly at x equals 2. Okay. This x less than or equal to 3, again, the domain is bounded by 0 at the lower bound. So that's why you have 0 sitting there. So that's a quarter times 3. So usual area of the rectangle formula. So a quarter times the width, which is 3. So 3 quarters. Greater than or equal to 1 or greater than 1, same thing. That's going to be now bounded by 4 because, again, going back to the domain, it's bounded by 4, that being the number, sorry, the upper bound. So usual 3 quarters. Notice the actual probabilities of these two are the same. Okay. All right, moving on. Last part of question 4, you had to show, going back to the question, you had to show that this left-hand side is equal to the right-hand side. Okay. All right, so left-hand side, probability between 2 and 3 is a quarter times the width, sorry, refocusing, which is 1, so that's quarter right there. And then the right-hand side, less than or equal to 3, take away less than or equal to 2. And of course, that is bounded by 0 and 3. That's bounded by 0 and 2. Notice I initially put the little x there. That's one of the common mistakes that people make. It's actually the capital X that you need to put, not the lower x, because the capital alphabet represents the continuous or even the discrete random variable. Okay, one of those notational things. All right, so then going ahead with the actual calculation, a quarter times 3, take away quarter times 2, and that's again as expected to be a quarter. So matching the left-hand side, hence the claim is true. All right. Okay, now question 5. So going back to the question, that's what the question is asking you to do. So that's the cumulative density function as defined in the integration form. Okay, and you have to calculate the actual CDF as a function of x and then confirm that f of b is equal to 1. So in each of those 4 different cases, you have different a's and different b's. All right, so first question, that's the CDF, a cumulative density function. Starts from 0 because I think I forgot to write it on my piece of paper, but the domain is from x equals 0 and 8. Okay, so that's why you start from 0. So there you go, 0 to x. Notice you don't put the 8 there because you need to get the general function in terms of x. So the end value there is always x. That's important to note. And then this here, the variable has to be t or some other, as long as it's not x, because you can't put the x and x there. You know, if you remember the second fundamental theorem of calculus, that's x, and that's usually written as in t. So that's why it's t replacing x. And then, of course, this is then dt, not dx. All right, so then what that means is integrate this with respect to t. And as usual, it's t squared over 64. All right, t becomes t squared and divided by 2, but 2 times 32 gives you 64 downstairs. And then evaluate it from 0 to x. And now the t gets replaced by x. Hence, you've got x squared on 64. Take away 0 over 64, which is 0. So that's the function, the CDF, the cumulative density function in terms of x. Once you've got this, and then you should be able to evaluate f of 8. And remember that 8 is the last value in the domain. Just going back to the question. So there you go. That's the 8 there. All right. So the last value in the domain substituted, then you would expect that to be 1, which is exactly what's happening. All right. So similarly, part B is a different little fx given. So this time you got given this. So it's originally 3 on 16x squared, but like I said before, every x now gets replaced by t, and this one is always x, and that one is always the lower bound of the given domain. Now for part B, the domain is from -2 to 2. So that's why I have now -2 there. And then you do the usual integration, and that's what it gives. Evaluate it at t equals x and t equals -2. Then you get this. One of those common mistakes is -2 cubed is -8, not +8. So make sure of it. So 16x cubed -8 becomes positive. So that's now my CDF in terms of x. Hence, now I should be able to plug in x equals 2, which is the upper bound of the given domain. And nothing surprising. It gives you 1. So that's that. All right, and then question 5. All right, so question 5, part C. And now this time the function is 3 on 2 bracket 1 minus x squared. And the domain, if you have forgotten already, I have certainly. So from 0 to 1. Okay, so that's that one. So every x gets replaced by t, and here the 0, you start from 0, and that's the x. So 2 and 3, all that, and evaluation gives you this. So that's the actual cumulative density function, or CDF, in terms of x. Okay, you can't have this f of x to be some sort of a single number, because it has to be a function. So now plug in the upper bound of the domain given, which is 1 in this case, and again, gives you 1. All right, last question of question 5. F of cumulative density function is written up this way, and now you had to remember that this 1 on e is a constant, so that survives the integration. Now you have to remember that integrating the exponential, you get the exponential back. And luckily in this case, the power is a very simple t. So you get t there, and you don't have, you could divide it by 1, but that's not going to change anything. And that one is now t. Again, you don't put the x there, it's the t, because you are integrating with respect to t. So that's going to be t. Evaluate it from 0 to x, and replace all the t's by x, replace all the t's by 0 respectively, then you get this. Now again, one of the common mistakes, when you do this added habit, you sometimes, I hope it doesn't happen with you, but sometimes you think that e to the 0 is 0, but it's actually e to the 0 is 1. So don't ever forget that. Then you get this rather clumsy looking function, but it still is a function of x. So believe it or not, that's your CDF. And let's see if you've done the right job by substituting the last value of the domain. Remember, it has to give you 1. So do all this, then you get 1. So I should be on the right track. Okay, so that's question 5. And let's moving on to the last question in the foundation section. And that is question 6. And it's what the question is asking you to do. Of course, you just got to do A and B, but looking at you have to use the functions from question 5, sorry. Now, out of A and B, I'm just going to do B, the quadratic case, and I trust that you could do the linear case yourself. All right, so here I'm just going to demonstrate the second case, the quadratic case. Now, what you're asked to do is you have to find the median, that's Q2, and part B is the quartiles. That's Q1, the lower quartile, which is the 25% mark, and Q3, the upper quartile, which is the 75% mark. That's why you have 0.25 there and 0.75. Okay, so question 6. Notice here, like I said, I'm just going to use the quadratic case. Now, remember the cumulative function for 5b was 1 on 16 x cubed plus 8 in bracket. And now part A, first of all, you got to find the median. So you need to set that equal to half. That's important, okay? Because Q2, that median is the 50% mark in the distribution of the data. So that's why you set that as half. So that's the cumulative function, the big F of x equal to half. And now this is basically now solving an equation. Though it's a cubic, but it's not too bad because x cubed plus 8 gives you 8. And therefore x cubed has to be 0 or x equals 0. So that's your Q2, the median. Part B, the lower quartile is the 25% mark. So same CDF function, but it's now setting at a quarter. So if you do the algebra, then you get x cubed plus 8 plus equals 4. And therefore, I'm sort of jumping here, but what I've done is x cubed equals -4. Okay, now anything with an odd power could be negative. So that's, you shouldn't be surprised by that. And hence, your x must be cube root of that. Another mistake is people tend to put plus and minus out of habit. Again, this is an odd function. So therefore, there should be only one solution for that. So you don't put the plus and minus. If that is negative, then there's only one negative x value to satisfy that. So that's why that's cube root of -4, or being an odd function. Not an odd function. That could also be interpreted as that, because you can have a negative. That's a negative cube root of cube root of -4 is the same thing as negative cube root of 4. Same thing. Okay. Or if you're in doubt, you can check that in your calculator. And the upper quartile part, similar algebra. So it's only 3 times bigger. So it's now 12, and x equals cube root of 4. Again, the only positive answer. So that's your Q1, and that's your Q3, and that is your Q2, the median. Okay. All right, so that about does it for this video. And like I said before at the beginning of this part 2 video, next video will be the start of the development part questions. So look forward to that, and I'll see you guys next time.